Hello students, in this video we are going to solve the questions and or numericals based on time differentiation property. So if the question asked in the exam and you have to solve the question with the help of time differentiation property, there are basically two types of question. In one question there will be a figure, and in another question there will be a equation. So both these questions will be solved based on the differentiation property. We will solve both the question one by one, but before that you need to know two things. First thing is differentiation of ramp function is always a unit step function. So always remember this thing. If you have a ramp function, you have to differentiate that so that ramp function will become a unit step function. And then when you have a unit step function, you need to differentiate that function again to get a unit impulse function. So if you have a ramp function in the question, that means you have to differentiate that ramp twice. First, that ramp will be converted into unit step function, which is defined or denoted by ut, and then ut will be converted into delta t, which is a unit impulse function. So this thing you need to know before solving such questions. Another thing is, as you can see, this is a line. O to A is a line, A to B is also a line. So that means we have to calculate, or we have to find, in this question the ft is given, but in this question ft is not given, rather a figure is given. So from this figure you need to first calculate the function ft. So how you will calculate the function of ft? By calculating the equation of this line. In maths we have already studied this thing, or this formula, which is y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1, where x1 and y1 are the coordinates of first point and x2 and y2 are the coordinate of second point. So when you will calculate the equation of this line, this will be x1 y1 and this will be x2 y2. But when you calculate the equation of line AB, the coordinates of A will become x1 y1 and coordinate of B will become x2 y2. So that way we will calculate the equation in y and x terms. So as you can see, in y axis you are keeping ft and in x axis you are having t. So once you get the equation in the form of y and x, then you will replace y with ft and x with t. So you will get your function accordingly. So this way we will solve the question. So let us take this example. First we will solve this example and then we will solve this example. So let us take this example first. In this example the figure is given, which is defined between 0 to 3. Between 0 to a, your function is line OA, and between point 2 to 3 your function is AB. So first we will calculate the equation of line OA. So what is the equation of line OA? It will be y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1. Okay. Now x1 y1 will be coordinate of O, which is 0 0, and x2 y2 will be the coordinates of point A, which is x is 2 and y is A. So 2 comma A. So let us put x2 y2 and x1 y1 in this equation. So you will get y minus 0 is equals to a minus 0 upon 2 minus 0 into x minus 0. You will get y is equals to a by 2x. As I have told you, y will be replaced with ft and x will be replaced by t. So you will get ft is equals to a by 2t. Now this a by 2t is between 0 to 2, so you will write 0 is less than t is less than 2. So this part is between 0 to 2. Now you will calculate equation of line AB. Again y minus, now what is the coordinate of B? This is 3 and a by 2. So y minus y1, that is a, because now 2 and a will become x1 y1, and 3 a by 2 minus a upon 3 minus 2. This is y2 and a is y1, and 3 minus 2, this is x2 and this is x1, x minus x1. So you will get y minus a is equals to minus a by 2 x minus 2, or minus a by 2 x plus a, or y is equals to 2a minus a by 2 x. Again y will be replaced by you can write directly 2a minus a by 2 t. This is between 0 is 2 is less than t is less than 3. So your function ft is defined by a by 2 t between 0 to 2 and 2a minus a by 2 t between 2 to 3. So this is your ft. Now as you can see, these are two ramps, and I have just told you that you need to differentiate this ramp to get the unit step function. So what will be df by dt? Your df by dt will be a by 2 ut, and 2a is a constant, it will be giving you 0 value, so you will get minus a by 2 ut between 0 to 2 and between 2 to 3. This is your df by dt. So that means ft is this. You will differentiate this function ft and you will get this thing. Diagram wise also I can draw this thing, which is between 0 to 2 you are getting a unit step function with a positive magnitude a by 2. So this is a by 2 ut, and then minus a by 2 ut between 2 to 3. So between 2 to 3 you are getting a function with a magnitude minus a by 2. If this is your ft, this is your df by dt. Now what you need to do, you need to differentiate this function once again, which is d2f by dt square, a by 2 delta t and minus a by 2 delta t between 0 to 2 and between 2 to 3. If I want to draw a graph, you can see at this point at t is equals to 0, your function is moving upward with a strength a by 2. So you will get an impulse at t is equal to 0 with a strength a by 2. Now at t is equal to 2, your function is moving downwards from here to here with the strength a by 2, and from here to here again with a strength a by 2. The total strength is a, but where? In the negative direction. So at t is equal to 2, your impulse is getting down with a strength minus a, and then at t is equal to 3, your pulses or step is moving again upward with a strength a by 2. So that means basically you are getting 3 impulses, 2 positive impulses and 1 negative impulses. Positive impulses are having magnitude a by 2 and negative impulses having double the amplitude, which is a. Now this thing we can solve mathematically also. As you can see, this is a continuous function because it is a ramp, so you can write between 0 to 2. Again, unit step function is also a continuous function, you can write between 0 to 2. But delta t is an impulse function which exists only at a particular point. So you cannot say that it exists between 0 to 2. Rather, you will say it exists at t is equals to 0 and at t is equals to 2. Again, this impulse exists at t is equals to 2 and t is equals to 3. So basically, one impulse at t is equal to 0, two impulses at t is equal to 2, and again one impulse at t is equal to 3. Same three impulses which we got through the diagram. So this thing can be written in the form of d square f by dt square is, you can combine this thing, this is a by 2 delta t, because it exists at t is equal to 0, minus delta t minus 2, because this is the upper limit and this is the lower limit. So upper limit minus lower limit, upper limit minus lower limit. Lower limit means it exists at t is equal to 2, so it will be divided by delta t minus 2. Then this is a negative sign, minus, it will be a continuous equation. This is delta t at 2, so which is delta t minus 2 and then minus delta t minus 3, because the last sample exists at t is equal to 3. So when you combine this, you will get a by 2 delta t minus a by 2 this and minus a by 2 this, will get minus a delta t minus 2 and plus minus and minus will become plus, so plus a by 2 delta t plus 3. So basically d square f by dt square, you will get 1, 2 and 3 impulses of plus a by 2, minus a and again plus a by 2. This is the final equation. So now after this we will take the Fourier transform and got the final answer. So once you get this equation, now we will take the Fourier transform both sides. This is d square f by dt square. This is a time differentiation property, and we know that the Fourier transform of df by dt is j omega f omega, and the many times you differentiate this, j omega will get the same amount of power. So you are differentiating this equation twice, so j omega will be having power of 2 or square. So this is j omega square f omega minus a by 2 delta t. Delta t is a Fourier transform 1. This we have already covered. So this is a by 2, then this is a delta t minus 2. So delta t minus 2, in this we are applying time shifting property. What time shifting property says? That function will give the Fourier transform, that is delta t's Fourier transform, which would be 1, and then shifted part is multiplied in the exponential term. That means if it is 2 e to the power minus 2j, e to the power minus 2j omega, and then plus a by 2 e to the power minus 3j omega. This is by applying the time shifting property. So j square omega square will be minus omega square. We can take it in this direction. So f omega will be a by 2 minus a e to the power minus 2j omega plus a by 2 e to the power minus 3j omega upon omega square. This is your final answer. So if you get something like this in the exam, you need to solve through all this method, or this is the flow of the solution. I hope you understand such type of question. Now we will take the another question in which an equation is given to you, and through that equation you will get the answer by using time differentiation property. So another type of question which may come in the exam in the form of equation. In this equation you can see that the function is in the form of unit step function. So first we need to convert this unit step function into impulse function. So that means we have to differentiate this equation. This is basically on the basis of differentiation property. So what you need to do, if this is the equation given, you just need to differentiate the above equation with respect to time, both sides. So this ft will become df by dt, this ut will become delta t. So accordingly 5 ut plus 2 will become 5 delta t plus 2, ut plus 3 will become delta t plus 3, and so on. So this is the conversion after differentiation, and then after this we just simply take the Fourier transform both sides. So df by dt, as we know from the time differentiation property, has a Fourier transform j omega f omega. Then this is 5. Delta t has a Fourier transform 1. Now it is delta t plus 2 that is shifted. So it will be solved by using time shifting property. So it is nothing but shift in the exponential term. So t plus 2 will be e raised to the power 2j omega, t plus 3 will be e raised to the power 3j omega, minus 2 will be e raised to the power minus 2j omega, and this will be minus 3j omega. And obviously delta t has a Fourier transform 1, so that means 1 is automatically multiplied everywhere. So that's why I have not written it 1, I have directly write the exponential terms. So now I will combine the terms e raised to the power 2j omega minus e raised to the power minus 2j omega plus e raised to the power 3j omega minus e raised to the power minus 3j omega upon j omega. Now if I multiply and divide with 2, it will become 10 by omega, and this will become 2j, which is e raised to the power 2j omega minus e raised to the power minus 2j omega upon 2j plus e raised to the power 3j omega minus e raised to the power minus 3j omega upon 2j. So this is nothing but sine 2 omega plus sine 3 omega, 10 by omega. So f omega is equals to 10 by omega sine 2 omega plus sine 3 omega, because e raised to the power j theta minus e raised to the power minus j theta upon 2j is sine theta. So from that trigonometric identity, I have converted the exponential term into sine function. So this is your final answer. So this way, if a question is given in the form of an equation, you can solve it by time differentiation property. I hope you understood both the questions, and both type of questions now you can solve. Even if you have any doubt, you can write it in the comment section. Thank you.